Initiate countdown and press sequence start.
Sequence start in 3, 2, 1. Sequence start.
Welcome to the Air Force Research Laboratories rocket site at Edwards Air Force Base, California. This is the home of the Propulsion Directorate Space and Missile Propulsion Division, a historic site with the likes of Kitty Hawk and Tranquility Base. Our mission for the last 50 years? To develop and transition advanced rocket propulsion technologies to the Air Force and the nation. In 1947, we moved from our headquarters at Wright-Patterson Air Force Base, Ohio, to Edwards Air Force Base, California. This is the home of real rocket scientists. We have over 400 government civilians, military, and contractors on site conducting basic research, exploratory, and advanced development and system testing. Our military personnel, active duty and reservists, are a great asset. They bring with them extensive field experience in ICBMs, space launch, and program management. Since 1947, we have grown to be a $2.5 billion national asset with 135 major laboratory and engineering facilities and 30 major active test stands.
All stations confirm readiness for test sequence by saying go or no go. Go, go, go.
There isn't a better place to do rocket science. In our bench scale labs, we synthesize and investigate novel new ingredients and materials. We can simulate space operations in our altitude facilities, handling nano-Newton spacecraft thrusters or 50,000-pound upper stage engines. Our sea-level stands can handle ballistic missile boosters and liquid engines up to 10 million pounds thrust.
5 psi on extend the quench.
The Mojave Desert is a great place to do our work. We're nearly the size of Washington, D.C., covering 65 square miles. Plenty of room to test advanced rocket propulsion technologies. Sharing the desert landscape with environmentally sensitive species like the desert tortoise, we remain mindful stewards of our natural resources. However, unlike other parts of the state, we are not hindered in our work by environmental constraints. With a budget of approximately $100 million, we conduct an impressive array of rocket research, both in-house and with our industry partners. In-house, we conduct basic and exploratory research in aerophysics, propellants, and materials application. Two examples of our in-house work are POS and ionic liquids. POS is the first, and to date only, nanostructured hybrid chemical feedstock in existence. We developed POS macromers and POS copolymers in 1993, and now there are over 16 universities and other groups around the world pursuing its incredible capabilities. POS is easily incorporated into polymers and plastics, radically improving the thermal and physical properties of the original material. The applications are nearly endless. We're currently investigating ultra-hydrophobic, water-resistant POS polymers for use in seals and coatings. Hydrazine has been a workhorse propellant for satellites, missile defense, and other Air Force applications for decades. However, it's highly toxic, requiring special suits and handling procedures. We're developing a family of ionic liquids that are non-toxic and have 70% greater performance than hydrazine. Besides our in-house work, we work with our industry partners through the Integrated High Payoff Rocket Propulsion Technology Program to deliver advanced propulsion technologies. We also work with other AFRL technical directorates to deliver integrated, revolutionary capabilities to the warfighter. We develop advanced solid rocket propulsion technologies for ICBMs and tactical missiles. Clearly, we can't do this by ourselves. With the help of the Materials Directorate, we're delivering future ICBM technologies to Air Force Space Command. That's not all. We're delivering aircraft-like operations to space. After initial Air Force development, we partnered with NASA for testing and demonstration of a liquid hydrogen engine that can operate for 100 missions before needing an overhaul. Working with the Air Vehicles and Material Directorates, we're delivering aircraft-like operations for space, for the Air Force, and the nation. It isn't enough to have aircraft-like operations to space. We have to be able to operate in space as well. We're developing advanced spacecraft propulsion technologies to do just that. In fact, we recently saw our Hall effect and micropulsed plasma thruster technologies flown on 2 satellites, TechSat-2 and the Air Force Academy's FalconSat-3. Currently, we're looking at developing multi-mode spacecraft propulsion to provide greater flexibility and maneuvering on orbit. What does the future hold? Aircraft-like operations to and from space, satellites zipping here and there, being able to reach anyone, anywhere on the globe in minutes. We are the future of rocket science for the nation.